This video will show you how to solve radical equations. A radical equation is an equation that contains one or more radicals. Radicals could be square roots, they could be cube roots, fourth roots, fifth roots, anything of that form. We would like to solve and check our answers. I've written 4 steps out. I think these will make it easier for us to solve the problems. So for step 1, we would like to isolate one of the radicals. Here's the first example. I have only one radical in this equation. Sometimes we could have 2, but this is 1, and it is already alone or isolated on the left side. So we could skip step 1. Step 2, square or cube both sides of the equation. So for the examples in this video, I've given you square roots and cube roots, but you could have other roots as well. Basically what you do is just take a look at the index of your radical, and that will tell you what to do to both sides. And so since this is a square root, the index is 2, I just square both sides. If it was a cube root, I would cube both sides, and so on. I raise both sides to the second power. Do you need to FOIL? For some of the problems, you do have to FOIL. However, for the first example, we do not need to FOIL because I just have one term, right? A monomial squared, so I could just square that. And the square root right here is also considered to be one quantity or one term, so I do not need to FOIL. You have to FOIL if you have a binomial squared, meaning 2 terms. When we square a square root, the radical goes away. That's the whole idea behind solving radical equations. We have to eliminate the radical so that we can solve for x. If you can't get rid of the radical, then you might not be able to solve for the variable. So that is why we square both sides or we cube both sides, because that will eliminate the radical. So right here, if I square a square root, I will just get x times x plus 3 equal to 4. We distribute. This is a quadratic equation. One way to solve is to set it equal to 0 and see if you can factor. In this case, we can factor our equation, and so we just go ahead and factor this. So x plus 4 times x minus 1, and we have to set each factor equal to 0, and if we do that, then we get that x is equal to -4 or x is equal to 1. The last step, check your final answers with the original equation. In this case, I have 2 solutions, so I have to check both of them. And you always check with the original equation. The original equation is the equation that's given up here. I do not plug in my solutions to anything you've written afterwards. So always the original equation. The reason we have to check is sometimes when you have an even index, like a square root or fourth root, your answer might not work, and so it would end up being a no solution. So sometimes that could happen. If you have 2 solutions, sometimes one of them doesn't work, and so you have to check. When we square both sides of an equation or raise it to an even power, it can introduce error into the problem, and so that's why we have to check our answers. But let me show you. So to check, in this case, like I said, we have to do it twice. So I'll start with -4, and we're checking to see if the left and right sides are going to be equal. So question mark, is that going to give me 2? And I'm substituting into the original equation without these exponent, without the 2. So let's check. Negative 4 plus 3, that's negative 1. Negative 1 times negative 4, that just gives me square root of 4. And as you can see, square root of 4 is equal to 2. So 2 is equal to 2. That means that negative 4 is a solution. I could box it. We're going to do the same thing with 1. Same idea, substitute it into the original equation and check. Well, this simplifies to, again, it simplifies to square root of 4. Square root of 4 is 2. 2 is equal to 2. Left and right sides are equal. So both of these solutions for this problem will work. So I can box both. Let's take a look at the second example. I'm going to keep the steps here next to us. Okay, so we're going to use the same steps. All right, so this equation, we also have a square root. We want to look at this carefully because the first step requires that we isolate the radical, at least one of the radicals, if there's more than one. If you look at the left side, notice that you have your radical and then we have minus 2x. Because of that minus 2x, this radical is not isolated. So you have to get the radical by itself without plus or minus other stuff, which means I need to do the first step. I need to add 2x, move it to the other side. Step 2, square or cube both sides. We are going to square both sides because index is 2 and we have a square root. Do you need to FOIL? So let's see. On the left side, this is just considered one term, so I don't have to FOIL. On the right side, this is a binomial. It is 2 terms, right? So we have to FOIL. So for this example, you have to FOIL on the right side. You can just write your answer, what you get when you FOIL, or you can write out 2x minus 1 twice and FOIL it out. I'm going to write it out twice so we could see what's happening, and then we FOIL it and continue the problem. On the left side, we just get x plus 7. You could write this out twice. We have to FOIL. And you also need to combine your like terms. So after I FOIL and combine like terms, then this is what you get. Okay, so I've already combined the like terms. This is quadratic, so what we're going to do is set the equation equal to 0, see if we could factor. I have to subtract x from both sides, which gives me minus 5x. And we also need to subtract 7, which gives us negative 6. From here, this is actually factorable, so let's go ahead and factor it. Just make sure that you factored it correctly. So always check if you're factoring, make sure that you check your work here. Make sure that you get negative 5 as the middle term. So once that's done, then we set each of the factors equal to 0, and we get that x is equal to negative 3 over 4, or x is equal to 2. So we have 2 solutions, which means I have to check both of the answers. So let's make sure that they work. So let's start with negative 3 over 4. And this is a fraction, so we do have to just make sure we get a common denominator and all that stuff. So we're going to check. You're just going to substitute . see if this left side is going to give us -1. All right, so right here, I need to get a common denominator. So we have to multiply by 4 over 4. The 7 over 1, multiply by 4 over 4. And if you do that, we get -3 plus 28 over 4. And right here, we're going to simplify this to plus, and then I could reduce 2 and 4, so I just get 3 over 2. That's going to give me square root of 25 over 4 plus 3 over 2. Take the square root, that's 5 over 2. Okay, so is 5 over 2 plus 3 over 2, is that going to give us -1? No, we are not going to get -1. So that will not work. Let's try 2. All right, so right here, we have square root of 9, right? -4. That's going to be 3 minus 4. So -1 is equal to -1. So in this case, when I substitute 2 and check, I do get that the left and right sides are equal. So this does work. So I only actually box one answer. Okay, we just box 2. We do not box -3 over 4 because that does not work. Let's take a look at example 3 and 4. They're on the same page. We're going to follow the same exact steps. Example 3 has 2 square roots, but at least one of them is isolated. Well, in this case, they're both isolated, but I have at least one isolated. I don't have to do the first step. We are going to square both sides. Okay, so raise both sides to the second power. We get that's a linear equation. I solve it just like a regular linear equation. 2 plus 10 is equal to 9x minus 3x. I get that x is equal to 2. So from here, we want to check our answer. So again, you're going to take your answer, plug it into the original equation without the squared part. So this comes out to be square root of 8. Right side also comes out to be square root of 8. Left side is equal to the right side, so 2 is a solution. By the way, I did not need to FOIL here because, again, when you have just one square root equal to one square root, we just have basically one term equal to one term, so we don't have to FOIL. Example 4, we have a cube root. The index here is 3. So when you have a cube root, we would have to cube both sides. The radical is isolated, so just raise both sides to the third power. When you cube a cube root, same idea as squaring a square root. The cube root goes away. Solve for x. And we get that x is equal to -4. Let's check our answer. So in this case, our solution works. Left and right side is both -2, and so we have our solution, which in this case is -4. Last example. Following the same steps. So this is a little bit different. This is a longer problem. I have two radicals, and for the most part, when you have two radicals where one of them is not isolated, you will have to go through these 4 steps. You would have to do it 2 times because you will have to eliminate the radical twice, as I will show you right now. Step 1 is not needed because I have at least one of the radicals is isolated. So I just directly move on to square both sides. Now, do you need to FOIL? In this case, yes, we have to FOIL. Why? You have to FOIL because we have a binomial here. On the right side, I have a square root plus 1. This is 2 terms, 1 and 2. So 2 terms. If you have 2 terms, that's a binomial. If it's squared, you have to FOIL. So we're going to write this out 2 times and then FOIL. Square root of x plus 6 times square root of x plus 6 is square root of x plus 6 squared. Anything that's squared inside of a square root makes the square root go away. So it's just x plus 6. Let's combine like terms, which would be those 2 are like terms, and also 1 plus 6 is a like term. The other thing you can do to just simplify this is you can subtract x from both sides, and if you subtract x from both sides, the variable x, that will go away. That will be 0. So I just really have 1 and 7 plus 2 square root of x plus 6. Now I need to, at this point, this is where you have to go through the steps a second time. Why? Because we still have a radical in the equation. Notice we started off with 2 radicals, and I was only able to eliminate one of the radicals, this one. I did not get rid of square root of x plus 6. That's still here. So if you notice that this is happening, you have to square both sides again. I have to go through these steps. So step 1, isolate one of the radicals. Well, this radical is not isolated because of that 7. So I need to subtract 7 from both sides. Also, I noticed that I could divide by 2. It'll just make the number smaller. Now, I'm going to square again. Subtract 6. So I get that. Now we need to do one last thing, which of course is we have to check our answer. So let's see what happens here. Square root of 4 is 2. That's going to give me square root of 9, which is 3, plus 1 is 4. 2 does not equal to 4. So this is a false statement. X is not equal to 3. The answer you want to write is no solution.